Hello guys, and welcome to the very first coding video here where we're going to be making a simple clicker game, a real clicker game. I'm going to be walking you guys through the process. You're going to be opening NetBeans and we're going to be creating a new project. And I'm not expecting you guys to be super hardcore developers after this. I am just expecting you to understand the basics so that you can change and customize the game as we move on. We're deleting the project that we set up in the first video because we don't need it anymore, and then we're going to be creating a new project. Select File, you go to New Project, and then you select the CodeName One just as we did in the first video. Just like that. And you hit the Next button. You're gonna give the project a name. I'm going with a simple clicker. I suggest you guys do the same as what I'm doing, at least during the startup here, so we have the same stuff. In the package name, I'm going to go with com.LokeHansen.simpleClicker. Once again, I suggest you do the same. We can change this later, just so we have the same stuff going on. In the main class name, I'm going to write simple clicker. I'm going to use a capital S and C. And then I'm going to be selecting the Hello World bare bones in the template menu. It means that we're going to be making like a pure code project without themes in it. So we're going to expand the structure up to the left. We're going to go into the com.LokeHansen simple clicker area, and we're going to find our only Java file. This is like the controller where everything like branches out from. This is all the code in the file for now. Basically what it does is it makes an empty app that says hello world. That is pretty much what you need to do about it now. If we hit the play button, we're just going to be firing it up, and then you can see how it looks depending on your rotation. It has hello world in the title and in the body, and that's no game. But it's gonna be, when we're done today, we're gonna have a very simple game. We are going to be spending a lot of time making the basics. The core part of this project is a form. A form is like a building block that manages everything. Let's just go with that for now. The form has a title at the top. We're going to remove this theme line here because this is actually where the CodeName One plugin decides how things are going to be looking, and we want to decide that manually. So we are removing the effect of the theme. We don't want to be having themes used. We're going to tell with codes how things are going to be looking. So we just add 2 lines in front of the theme line, and then we're done. All this form stuff here, you can see it says hi world. This is what we saw before. We're going to be marking that. We're going to be cutting it. Control C, CMDC. It's now gone from the start area of the code. This is the things that are run when we start. We're going to write something new here. We're going to write restart game, and this means it is going to try to call a function called restart game when it starts, and we're going to be making that now. We're writing it here, public void restart game, and then we're going to be pasting the code from before in here. So we just move the code from one area to another, and this is because we want players to be able to restart our game, not just start it up at the same time. We want to like move codes into small separate areas instead of having everything written in one place. So we're gonna have a lot of files dedicated to different purposes. Right now, I'm sorry, I'm just fiddling a little with the code here. I seem to have missed character here. And it's okay if you make the same mistakes as me, because I'm gonna be correcting them as we go. So yeah, I'm sorry. I'm a little new to the comment coding kind of thing here, but this is how it should look. If you start up the game now, it's going to work as it did before. We just moved the part of the code that told what was going to be going on to another place where we can control it, and we can tell it to do all sorts of other things. We're going to be removing that form, and that is because we want to make our own form. This is like a building block, and we're going to be extending it. We're going to give it new functionality. So you right click and you select new Java class. We're going to write core component touch form, and that is because what we want this form to do is to keep track on the touch things that are going on. This is where everything related to touch is going to be going on. In the package, you're going to be selecting the LokeHansen simple clicker so that we can access it easily. Now we have a new thing here. I'm just going to be deleting these comments. Throughout this coding, I'm going to be writing some comments and deleting them. They're just there to help. It's not actual code. You do not need to write it there. So we're going to be extending something that is already written. Consider this as somebody made something and we're just going to be customizing it to meet what we want it to be. So we are building upon the form and we're adding new functionality, customizing things in it. We're going to be copying the name because we're going to be needing it before. So now here we're going to be making something called a constructor. You don't need to understand these things, to be honest. I'm going to be telling you guys when something really important you need to understand is. For now we're building like the skeleton. A form gets a layout that pretty much decides or defines how things are going to be looking on the screen. We still need to do that because we're building on something that requires it. So what we're doing is that when we make our custom form, we're just telling it, hey, to the original building block, send this information back to it because it needs it. The next thing we're going to be doing here is we're going to be removing the annoying title area at the top of this form, the first hello world. It's a fixed component area that CodeName One just decided had to be there. So because we are making something custom, we can now remove it, whereas we would be forced to have it there before. I can see that I made a bummer here again. I'm sorry, I'm going to try to not make too many errors. I was extending a component. We are, of course, going to be extending the form. Sorry, guys, but yeah. I'm going to practice more in between this video and the next one. The layout here is something it has a line under. It means it doesn't really know what it is. We're just going to be typing it again. Then we can hit Alt Enter, and then it is going to suggest every time there is something with a line under it, something it doesn't understand, then you can hit Alt Enter and you're going to be importing some kind of class so that it understands what it is doing. That is what I'm doing each of these times when it comes up with the small menu, and you're going to be just, you can also write the text. It says import count.codename blah 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 at the top. You can write it manually. This is just like doing it a bit faster. Again, here you can see Alt Enter shows hints, but it was just a typo, so it can't really fix typos for you. But anyway, we now have our custom form. It is exactly the same as it was before, only it is telling itself to remove the title. We're going to be adding other things to it. We're going to be adding the functionality that keeps track of where somebody is touching or dragging on the screen. Right now, not. It is something we're going to be adding to it today because we're going to be making a game that you can tap in. But for now, we just want to have bits and bytes of the structure made as we move on. And as you can see, I'm writing these comments in between the code. You do not need to do it. It's just in case you guys grab my source codes. These lines are there to help you understand what is being done. Now that we have something different, we have a core component touch form instead of just a form, we're going to have to add it in this main file. So we're writing private core component touch form, and we're going to be giving it a name, and it's called touch controller. Whenever we want to work with this, we're going to be calling it touch controller. So this is like the main component. The touch controller is where every magic is going to be happening. It's also where we're going to be doing all the drawing. Everything is going to be originating from this one thing that we are building upon. In the restart game method, in the simple clicker Java class, we were doing something to the original form before. Of course, now we need to do something with the touch controller instead. The first thing I'm writing here is I'm saying if it exists, if it isn't null, just means that it's blank, then we need to set up stuff. It means that we're just loading, we're starting the game for the first time, so we need to tell the game all sorts of stuff. If not, and that is in the else part, we're just going to update some stuff. If it isn't null, it exists, and we need to update stuff, else we're going to be making a new one. So when you restart the game, you can do two different things. You can like set up things for the first time, which is what we're doing down here now in the else, or you can do different things because you want to load stuff and give percentages or whatever it is. The new grid layout 1.1 that I'm writing in the parentheses is telling the core component form that everything we put in there is going to be in one space on the screen, and that is the information it is sending back to the original form. So that is just making sure when we put something in there, it's going to fill the entire screen. So it's like a lot of weird code, but it's very, very simple stuff. The next line here is, again, we're telling the touch controller to remove its own title. So if for some reason it's still there, can be some compatibility issues with other devices and ways to do it, it's going to be removed now. The last thing we're doing is we are writing touch controller.show. It tells the main program file here to show our container. If we don't do it, nothing's going to be coming up on the screen. So we now changed the form into something new where we can do our own custom things. What we did to start with is we removed the title. We made sure everything is like filling up the entire screen. And that is pretty much what we have done so far. This is like super important stuff, but it's like really boring, and I know, but we need to get all these basics done first. We're going to be making a new Java class now, and we're going to call it graphics controller. This time I right-clicked on the LokeHansen symbol clicker, so the package has already been selected. You may already get this, but the graphics controller is going to be in charge of everything related to graphics. So the other thing we made is related to touch, and this is related to painting, drawing on the screen. Once again, here I am hitting Alt-Enter to select this import com.codename.ui.component because we are extending a component, and this time it is in fact a component and not a form. These are details you don't need to worry about. What we're doing here is creating something that can animate. In order for us to animate something, we need to tell in the code when do we want the image to be refreshed. For that, we're making a variable called last rendered time. It is a long, meaning that it can be a huge number, and we're going, each time we repaint the picture on the screen, we're going to give this variable the millisecond value of the time right now. So we can always compare and see how many milliseconds has it been since the last time we updated the graphics. So this is like functionality where we can control how often we need to update the image. Once again, here we need to import the graphics so it knows what we're talking about. Hit Alt-Enter and select import com.codename1.ui.graphics, or you can write it. The function, the method here, paint background graphics G, is something that already exists. As with before, the form already had things, but we are customizing it to our needs. This means that we need to do the super thing again. This is something you need to do just to say we're changing something and we want to do our own stuff, but we need to make sure the original thing gets its data. The next thing that we're doing is that we're going to, the system is doing something already. So everything related to graphics may have been changed for some reason that we don't know. So we want to be saving all the information about how is the device already working with graphics right now. Has it been moved, changed, scaled, all that stuff. So we're saving that. Is it anti-aliased? Is it translated? So we're just grabbing the information about how things are before we do anything. We're saving it, and then we're going to be doing all our things, and before we like hand over control again, we're going to be setting things back the way they were, so that everything else is going to be working as it should. So like we get it in one condition, we do sorts of weird stuff with it, and we hand it back in the same shape as we got it. The g.getTranslateX and .translateY that we're going to be writing has to do with, has things on the screen, has the graphics object been moved in one direction or the other. Again, not important stuff. None of this is important. You don't really need to know anything about it. I'm just sort of telling you guys a little bit about it. It's just something we need to do. And I hope that by just explaining it a little bit, you guys can understand, once we get a more complete game, where do you want to be changing things and what effect is it going to be having and what shouldn't you change. Because messing around with these things is not going to affect your game in any positive way. It may just mess up things. So we start by grabbing the information, has things been changed, and then we change them in the opposite direction if they have been changed. So we have graphics that is completely unaffected by anything, at the right position in the screen before we do anything with it. We're going to be doing our stuff in the middle, and then here at the bottom we're going to be setting things back the way they were when we got them. Again, I know it's like super boring stuff. It's not making an amazing game. It is like really bummer, but this is just one of those many core things that need to be in order before we can do all the cool stuff. And it really means that the first video here is a lot of work compared to what we get out of it, but once we have these things in place, we can start moving into all the interesting stuff. So it's super important, I feel, to go through these things with you, so again, you know where to do things and where not to do things. I'm copying the graphics controller name here, and just as we before had to tell the main file that we wanted to be working with the core component touch form, we now also need to tell it that we're going to be working with something that is a graphics controller, something that we made. It has no idea what it is. The private that I'm writing just means only this file is going to have access to it. Again, so not important, but you can also write public, which means that other files can get access to it. So once again, we go down here to where we choose, are we like loading the game for the first time, are we resetting it, what's going on, and we're going to add G is what we called our graphics component to the touch controller. As I said before, the touch controller, the form is like the main building block. We're just going to really be using it for touch registration, but it is the thing that is shown on the screen. So we are adding the graphics element, the thing that is drawing onto it, and then we're telling the touch controller, the like main part of the entire game, to register it as animated. What that means is that it's going to poke it all the time to ask it, do you want to animate now? Do you want to animate now? Do you have something new to draw? And that is where the entire animation, moving images, doing anything on the screen comes in. The form is asking the graphics controller, are you ready to do something now? And that is what we're going to be looking into now. The animate method is another one of those things that need to be overwritten from the existing thing. So what we're going to be doing here is the touch form is asking it all the time, do I animate? Do I animate? Do I animate? What we're doing here is that we're saying if the current time of the system right now on the device, if that time, if we subtract the last time we did an update, if that value is larger than or equal to 20, then we want to draw new graphics. You need to move things on the screen, whatever you want to do. And then we want you to remember that right now, the system current time millis, the milliseconds of this very instant, was the last time we updated the images. and then we say return true. It means that it tells the touch controller that yes, update the graphics, draw something new based on what is going on in the paint background graphics G method down below. Now we have a touch form that is constantly asking the graphics controller, should I do something new? And we have a graphics controller that is saying every 20 milliseconds, yes, please draw something on the screen. What we're going to be doing now is just, we're going to be making a rectangle on the screen. We're going to be making a background. Right now there is nothing there. G.fillRect means make a rectangle that is filled with a color. We're starting at 0.0 on the screen, which is the upper left coordinate of the screen, the upper left corner. It is going to have a width equal to the width of the device screen. We're probably going to change this later on, and it's going to have a height equal to the height of the device screen. So basically this G.fillRect00 display blah 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 line is saying draw a square filling the entire screen. This is like make a background, a blank background, nothing that moves. This is just making a rectangle that covers the entire screen, and we're going to tell that we want it in some color, and for starters we're just going to go with black. We're going to talk a lot about colors later on. For now, please just like accept that 0x and 6 zeros means black, and 0x and 6 Fs means white. We're going to talk a lot more about colors. We're going to do it in a smarter, more meaningful way. For now, we're doing the colors like this. We're going to be working with a lot of different colors and shapes and stuff like that, but it's the more advanced stuff that we're going to have fun with as we go deeper into the concept. Just for the sake of demonstration, we're making a small rectangle here. It is drawn at 100.100 in the screen. It is 100 pixels wide and 100 pixels high. Just making it. We're writing draw rect, which means that we are only drawing the line around it. We're not filling it with the color, so we're just drawing a thin line of a square that is 100 pixels wide, 100 pixels high, and we're drawing a rounded rectangle as well. As the name might imply, this is a rectangle with rounded corners, and we are using 20 pixels as the rounding size for the rectangle. This is just to show you guys how it works. So, I messed up. A small mess up, but an understandable one, and it's a pretty cool way to show you guys what happens when you mess up. You get an error down below with links in it, and when you hit the link, it's going to tell you where you did something wrong. What we did wrong here is that we forgot to say that our G, our graphics controller, is in fact a new graphics controller. This is what we need to do down in the else part, because this is the first time we're starting it, so we need to tell it that G is a new graphics controller. And I forgot that one line, which of course is like super stupid. So it's like, yeah, I want to do something with this G that you're telling me to add to the form, but I don't know what it is yet. And yeah, we're telling it that now. You can see a few lines above, we're doing the same with the touch controller. We're calling it a new core component touch form. We need to do the same here, so that G is a new graphics controller. So there we have it, guys. Our black screen with two rectangles on it, one with rounded corners. All your base art belong to us, pretty much. So not really perhaps that impressive for 20 minutes of coding, but let's try to do something a bit more fun. Let's try to animate it. We're going to make something called a counter, basically a number that is going to be increasing all the time. I'm calling it frame shown, and int means that it's a number. And in the animate, in the part where it says yes, please do something, we're going to increase that value. Writing plus plus, it means take this value and give it one value higher. In the drawing area for these rectangles, I'm replacing some of these numbers with frames shown, and that is the variable holding this number that is increasing every time we update the graphics. What this means is that the drawings are going to change. They're going to be different depending on what this number is. Because we don't want things to go out of control, we're saying here, if this number is larger than or equal to 200, set it back to 0. And there we have a very small animation. It is running 200 iterations. It is changing 200 times. The one is moving. Its X and Y position is changing, equal to the amount of frames it has updated, and the other one is becoming rounded more and more based on the same number. So this is just to show you guys how you can do simple animation stuff. For now, let's delete it. It was just to do something to show you guys that we can in fact animate stuff. We can do all sorts of really cool stuff, and we are going to, but we're getting a bit more back on track now in order to get things. We need like a foundation that we can work on, so things will be more efficient in the future, and it will be easier for us to work with things. That also means that something such as making a background is getting its own class. We are calling this new class graphics background. I'm starting it with graphics so that we know this has to do with something that is being drawn on the screen, and background should pretty much tell us in the future when we have loads of files that this is where we are working with the background. So instead of us drawing the background in the graphics controller as we were before, we're going to move that code in here. So if we ever want to change the background, we want to make something skies or stars or explosions or whatever we want to have going on in the background, we have this entire file where we can do everything about it. And that is better. Once again, we hit Alt Enter to import this graphics file so that it knows what we mean when we're writing graphics. We're making this draw method. It is getting the graphics component. You guys don't need to worry about that. It just means that we are sending it, we're allowing it to do something on the screen if it uses G, and that is what we're doing here. Once again, we're telling G to set the color to black. We're telling G to make a filled rectangle that is filling the entire screen. So once again, we're just telling it make a black background. That's all we're doing in here. I expect us to be making more interesting backgrounds in the future. Like if you want a scenery or something, then we have this one file that is going to do it all. It also means that if we want to have different background options, we can do that stuff in here. If some of you guys come up with a really cool background code or image or something, then we can do it in here. We're doing something else, and that is we are setting G set alpha to 255. It just means we don't want the background to be transparent, which makes sense because there is nothing behind the background. We're copying the graphics background name, and then we're going into, we're just going to be saving this. We're not going to be doing more with the background right now. We're just going to be keeping it. We're going into the graphics controller, and here where we made the background before, we're just going to be deleting that stuff. And then we're going to have this graphics controller. We're going to paste this in. We're writing .draw, putting the G in there, and we're just in this graphics controller, we're telling this one at this point, tell this other thing that we made to manage the background to do its mojo. That's all we're doing here. So instead of having the messy background stuff going on here, we just like outsourced it to another file. We can do that with a lot of things, frames, buttons, all stuff. Make it in files that are managed by files, so that things are easy in the main files for structure and outsourced. We're going to be making a new class once again. That's because we want to draw a player's score on the screen. But first I want to make another thing, for now at least. I'm calling it shared data. There are some things, especially in games, numbers, information that you want to access both when you're drawing, when you're calculating, checking, are you leveling up, can you afford to buy this item, all sorts of stuff. These variables, this information is something it could make sense to have stored in one place with this public static information, as I write before, which means there is only one of these. So no matter who accesses this variable name, which everybody can get, or all files, it is the same information. So we can update it from many places and we can get it from many places. We're making 3 numbers here: player cache, player taps, and player cache per tap. Should be pretty self-explanatory. Player cache, your current balance. Player taps, how many times have you tapped. Player cache per tap, what do you want to give the player each time they tap. Down below we're making some touch variables. Also good information that we need to know when we're calculating all sorts of stuff. What position on the screen did the player touch the last time? What is the X and Y position on the screen? The last thing I wanted to do right now is make an RPS. Think frames per second. How many milliseconds do we want to wait in between the animation? We could just write the number. Now I'm putting in this RPS instead. I'm writing shared data.rps, which means in that file, shared data that we made, take the number from RPS and put it in here. This allows us to do all sorts of calculations in the future, because we know if we want to change this number and it should affect some kind of animation, then we don't need to work with a number that we need to change everywhere. We're just going to be changing it in one place and everything is going to be affected. We're making a new class now. This is going to be for the player score. We want that written on the screen, which means that it's a graphics and it's a player score. So when we see this name in the future, we know it's something going on the screen, and we know it is related to the score of the player. That is what goes into the naming, at least. In this project, I'm going to try to keep things simple in that way. I hope simple. We're adding something in here that we could have another place, but for now, we're trying to keep things really simple. I want to change the color to white because we have a black background and we want to be able to see what we are writing. Texts are called strings, and the string that we are going to be writing on the screen is called score to draw. That is a name I'm giving it. You can call it whatever you want. The string is made up of a $sign and the player cache value from the file we made before called shared data. So all we're doing here is saying the stuff we want to write on the screen starts with a $sign and then that number. If you change the $sign to a euro sign, that's what's going to be on the screen. The next thing we're adding here, draw string, is the code to actually put the string on the screen. The first thing you need to tell it is what to draw, and we are writing score to draw, so that is the text from above, and then it asks, where should I do this? I want it centered at the top of the screen, so once again we are saying display, get instant, get screen width. That is the width of the screen, and we're dividing that by 2, so that is the center of the screen. The next thing is that I'm asking for the current font we're using and the size of the text that we are adding, and I want to subtract that as well. So we move halfway into the screen and halfway of the text size backwards, meaning that the entire text will be centered. So this is, again, perhaps you don't really need to know this right now, because this is probably not what you would change if you were to customize the game. Later on, we're going to make new things for this as well, but for right now, we just want a very simple clicking game where you can just tap and get a value. That is the goal for today. Get all the basics in place, and then later on we're gonna make all the cool stuff. I'm moving some of these things. I am using variables here instead, mostly for overview, so you guys can see what's going on, because it was getting pretty large. So the score position X, where are we going to be writing this? We're starting by half of the screen. Next, we're going to change this value. Where on the screen, center-wise, are we going to put it? We started by saying in the middle of the screen. Great. Next step is to go a little bit more backwards, exactly half the width of the text. So I know, guys, it's super geeky, and like I said, you don't need to 100% get this right now, but I'm explaining it anyway, and I'm not expecting you guys to be super developers or anything based on these videos. This is the first video, so you guys tell me, am I explaining too much or too little about the different parts? But I hope the more I say, the better it's going to be for you guys to edit it once we have a real game going on. So I'm taking the scroll position and I'm subtracting half the width of the text from it. I think that I want to possibly move the information about the screen size into the shared data. The first thing we need to do, and I forgot that when we were starting, is we need this graphics information here as well. We cannot draw anything without having the graphics object, the G, that we are sending here. So we need to have this draw method. Public static means there is only one of these, and anybody can tell this to draw as long as they send the graphics object, the G, and that's what we're going to be doing from the graphics controller. So I'm thinking that we're just going to be moving this really to the shared data. I think that might be a good idea. So as you can see here, we have all this display, get instance, get display width, and get display height. Every time we need to know anything about centering stuff on the screen or drawing it at the right side or the left side, we're going to be needing this information. So in this shared data file, we're going to make these device variables, and it is not just to shorten the length of our coding, because I don't really care too much about that. It is think about if you want to scale things to a specific width. What if we code things and we have some speeds, things are moving or something, we're calculating, and we wanted to have a specific ratio or something, then we can actually change this number in here and say the screen width is never going to be more than 1000. So if you have a device with a screen that is wider than 1000, we can just say we don't really care. In this game it is only 1000, and then we can draw something in the space around it. Stuff like that we can do when we have these variables one place and we just access those. So even if we don't want to really do things 100% to the way the device screen is, we can fake it and we can move around it. It gives us more flexibility, and for me as a developer, flexibility is really important, because sometimes you can't make it, you need to fake it. Sometimes it's just resource-wise way too demanding to do things in one way compared to another. For now, we have this information about the width of the screen stored in the shared data. Once again, here we needed to add a void here. It means that whenever somebody's telling us to do this, we don't need to give them a reply, we don't need to tell them back any number. Again, not really important, but so we copy this graphics player score name, go back into the graphics controller, and here we just say graphics player score draw, and we put in the G. So once again, we're saying now it's time for us to draw the score. You there, over there, it's your job to deal with the scores, do your thing. And there we have it. We now have $0 on the screen, which of course is because we cannot earn anything yet. It is exactly where we wanted it, centered at the top part of the screen. Everybody's happy. We can now make a black background and we can write a white text on it. Not that important. Oh yes it is, because again guys, foundation, super important. We moved into our core component touch form again, and that is because now we're going to be looking into what happens when somebody touches the screen. In this touch form, we're going to do pretty much the same as we did in the graphics controller. We're going to have like the overview. The first thing we're doing is we're going to override some existing methods that already exist We're customizing them to do what we want. So we don't really care what they did before. We need to make sure that when a pointer is dragged, when you're dragging on the screen, it's gonna do what we want and not whatever it was going to do before. The same when it is pressed, when you tap, and the same when you release the finger from the screen. We can do a lot of stuff in here, calculating taps and all that stuff, but we don't want to. This is like a controller. This is like the boss of this pointer draggy division touch area. What we want to do here is say, oh, somebody pressed something. Let's save the coordinates of it in the shared data area. Somebody is no longer touching. Let's set it to 0. And then let's tell some other file to calculate how much the player is going to be getting, or to draw a missile on the screen, or a panda, or whatever it's going to be. So what we're doing here in the pointer pressed method is that we're saying when somebody's pressing, set the touch X and the touch Y variables to that number. This is the number, the coordinates on the screen. So whenever you press the screen, we're going to save the exact position. Whenever you release again, when you remove the finger, we want to set the number to 0. So this is pretty much all that we're doing in here. We're checking, are you pressing? If you are, where are you doing it? Save it so that we can draw something there, or from there, or to there, or whatever we want. If you release, set it to 0. Then we know nobody is doing anything. The next thing we want to do here is, right now we're doing it here. This is the dirty coding. It does not belong here, but for now, just because we are testing things, we are saying the number in the shared data, the player cache, make it larger, equal to the value of the player cache per tap. So what we have now is actually a game. We have a clicking game where a centered number that is white with a $ before increases by 1 every time we tap the screen. This is like the basics of a clicking game. You now have your very own clicking game. It's working, nothing fancy. That is what we're going to be adding. For now, we want to take this information that we use to test, and we're going to make a new class for it. We're going to hire somebody to do the thing about calculating what should we give the player whenever a touch is registered on the screen. So we are making a tap cache calculator. That is what I'm calling it. Maybe the worst name in the world, but it is actually what it is doing. It is calculating how much cache we're going to be giving when somebody is tapping. In this tap cache calculator, I'm making a method called reward player. It is public, means anything can tell this tap cache calculator to reward a player, and it is void, meaning that it's not going to tell anybody that yes, I did it, or the player has this much money now, or anything. When this method is called reward player, the player cache amount is going to increase by the amount that we have in the player cache per tap. So if you change that to 10, you're gonna get $10 each time you tap. If you change it to 100, you're gonna get 100 each time. The next line we're writing here is that we're making sure if it is 2 billion or more, we're setting it to 2 billion. This is like a safety for now, because the integer, the int number, has a range from like minus 2.2 billion to plus 2.2 billion, and we don't want to break anything. We do also increase the player taps value by 1, so that we can actually keep track of how many times has the player tapped the screen. And again, if the number is more than 2 billion, we're just setting it to 2 billion. So we're going into where we were before in the core component touch form. In the pointer released, when you remove your finger from the screen, that is when we are rewarding a player. So whenever you tap, it is saving where did you tap, but when you actually finish the tap, when you remove your finger, it is going to reward you based on whatever the tap cache calculator decides you need to get. So we now have a bit of a better structure on it. We don't actually need to have this tab cache calculator thing in here. Probably gonna move it. For now, this is where it is. We're gonna be making a new class because we want a tab text. If you're wondering what a tab text is, guys, then it is 2 seconds. I have somebody waking up here, so let me just pause it. Alright guys, back again. I'm sorry about that, but yeah. 3 a.m. here in Denmark. So, a tab text. It is what is going on the screen when you tap. You often see this coin or damage value or something that is moving to a different part of the screen originating from where you tap. For now, we're just going to make a tab text. It is going to have the value that you are getting when you tap, and it's just going to be moving in one direction on the screen. In order for us to have this, we need some numbers. We need the X and Y position on the screen. We need the actual value. I'm adding in an A, which is the alpha, the transparency, and S, which is the speed. How fast are we going to be moving on the screen? This here, the new tab text, is where we're going to be sending these 5 values, and it's basically just saying when I am making myself, I need to do so with the values that you are sending to me. Again, this is a part of the coding that isn't really that interesting, perhaps for you guys. The more interesting thing is what we're going to be doing with these numbers in a little bit, because that is where you can tweak things, and I do think that is the more interesting thing. Here we have a move method. This is how the tab text is going to be moving every time it moves. So what we're saying is the Y position of this, that's up and down, we're going to decrease that value by the value of S, which is the speed. If we make it smaller, it's going to go higher up. If we make it higher, it's going to go down. If you replace the Y with an X, it's going to go to the sides. You can also do both things. We're doing the same with the A, the alpha value, so it's going to be more and more transparent. The last thing we're doing here is we're making a method to find out, should we remove this again? What we're doing here is we're saying if the A value, the alpha of this, is less than 10, if it's almost invisible, or if the Y value is smaller than 0, if it's out of the screen, this is considered dead. So whatever we're going to be making that is in charge of these tab text can remove it again. And that is important, because if we don't remove it, it's going to be consuming memory on the device, and we want to remove everything as soon as possible when it isn't needed. Note that if you change the Y to a plus, you need to, instead of 0, have the screen height value that we made in the shared data. If you change the Y to an X above, so it goes sideways, you need to check for an X value here instead. Now we're going to be making something to keep track of all these tab text, because we're going to have many. It's a graphics, it's going to be drawing, tab text. We could also call it controller or something. The reason we need more is when you tap, we create one of these text and it moves, but you may tap 100 times before it's out of the screen, depending on the speed you give it. So we need something to keep a list of all of these tab text, and that is what we're making here. We're making something called an array list, which is basically just a list of tab text where we can say we are now controlling one more or one less, or remove number 7, stuff like that. So this is just a list of all the tab text, and we're calling it tab text. We are giving it public access. We don't need to, but for now we are. Once again, we have these lines under, meaning that the program doesn't really know what we're talking about, so we're going to import the array list file that explains what an array list is to the program. So now that we have this thing that can manage a list of tab texts, we're going to give it a method that creates one. We have made like the body, but this here is where we're telling it to make a new body with specific values. Here, as you can see, we have the same like 5 numbers. So when we tell this controller, this graphics tab text to do something with these 5 numbers, it then says, okay, I need to make one of these. I'm taking my list and I'm making a new one and I'm putting it in the list, and that is what is going on here. So whatever numbers we send to the add tab text is what is going to be used to make a new tab text on the screen that is going to be saved in the list of tab texts that this thing here is going to manage, clean up, and all the stuff that we need to do. We can do loads of more advanced stuff, and we are going to. For now, again, this is like the super basics. It's a structure that we need before we can move on and do the cool stuff. This manager, sorry guys, is going to be in charge of adding tab text, but also removing them. It's going to be in charge of drawing them. It's going to be in charge of moving them. Everything that we could do with the one tab text, this one needs to be able to do for all or 1 or 2 or 3 or any amount of them. We're making a loop. If you just write FORY, FORI, and hit tab, it's going to write these 3 lines for you, and then you just customize parts of it. So FORI, then it's going to make this loop for you. We're changing it so it is looping from number 0, which in programming is the first thing, not 1, 0. So from 0, we start with number 0 and we continue as long as there are more things in the list of tab text. That's the size. As long as there is something in the list, go to the next one. For this one, that is the I. If tab text that get I, if this 1 is dead, that was if it was transparent or out of the screen, then remove I. Then remove this one from the list. That is what is going on here. Check all of them, ask them if they're dead. If they are, remove them. That was the remove but tab text. The next one here is pretty much the same. We're making the same loop as we did before. This time around we're going through all of the tab texts and we're just going to say dude move. This one here, the one we're getting I, the one we're looking at now, move. And we made its own move code so it knows what to do. It's going to move on the screen and become less transparent. We could have all of this going on in one little method because we're pretty much doing the same thing. We're doing something for every one of these, so it would be more efficient for us to have one that just says go through them, start by asking, tell it to move, then check if it's dead, then remove it. It would save us a lot of loops because we're looking at everything 3 times now. But for simplicity, right now, for the structure, we're doing it like this. The next thing that we're doing is we're making a draw method. Once again, we're doing exactly the same thing, but we're needing this graphics G object. In here, we're going to say for everything in the list, once again, for every single tab text we have in the list, draw it on the screen and draw it where the X and Y position of this individual tab text is and make it as transparent as the A value of this tab text. So we're starting by setting G set alpha, that's the transparency. We need to make it as transparent as the A value of this particular tab text, that is the I, that says this one, this number is going to be this transparent. Then we move on to the next line and we say, okay, now that we have the transparency in order, draw a string, a text on the screen. We have done that before, but this time we are going to be drawing the number. We're going to be adding the $ as well, just as we did before, and then we're going to write plus, means we're writing more than that, and we want the value, the V, from this one, this I, this particular tab text, because perhaps we're using a combo and they're going to have different values. Perhaps if you tap here, they're going to be worth like $2, here $5, whatever we want to do, they can have different values. So we are taking the value from the particular tab text and we're taking the positions, the X and Y of it, and we're saying draw it here. The last thing we're going to do is make one method that does all of these things, but instead of doing it, it's just saying do thing number 1, then do thing number 2, then do thing number 3. Like I said before, this is not the most efficient way to do it, but I hope it perhaps the split up helps explain what we're doing by keeping things very focused on one thing at a time. I know it's probably still a lot to take in, but what we're doing here is we are saying whenever we are told to manage all tab texts and we get the graphics object, we start by drawing them, then we move them, and then we remove the ones that are dead. Again, this is a bad order. I just had a typo here, because we should probably move them first, then check if some of them are away from the screen, and if they are, then remove them. But for now, we're just doing it in this order. You can swap them around, but there could be things that, like perhaps if something is right outside the screen, but we have an effect on it, an explosion, an aura, something, then that part of the tab text might still be visible and it would give some kind of jitter. There are many ways this can work. For now, it is just really making a structure, keeping everything separate and making sure that it works. We're going to be optimizing it a gazillion times. We are going to make it more fun and better looking and all that stuff. But for now, we copied the name of the manage and we're putting it into the tab cache calculator. This is the file we made that decides how much money are we giving the player. Now we are telling it, when you have given the player something, at the bottom of this list, tell this graphics tab text controller that manages all these tab texts to make a new one for the list. And it has to make it at the position of the last touch the player made. So once you release the finger before these values are set to 0, make a tab text at the X and Y position of the player's finger on the screen when they tapped, and what you're going to be writing in this tab text is the same amount as you are giving the player cache per tap. The alpha value is 200, that is how transparent it is. 255 is completely visible, 0 is completely transparent. The last number, 8, is the speed it is moving on the screen. How many pixels is it moving every time the screen renders for every update. So let's check it out now. We should now have everything as we wanted to, except for one thing, and that is of course telling our graphics controller, the one in charge of everything on the screen, that it needs to manage, it needs to tell the dude we hired, the code we made to manage the tab text, we're going to tell it to manage them and draw them. So this should be the fruits of our labor. This is what we are finishing up with. We now have tab texts. Change the 8, they get a different speed. Change the 200, they have a different transparency. Change the -1 to a +1 and things are going to be moving in the other direction on the screen. You can change the Y to an X. It's going to be moving sidewise instead. Guys, this was about an hour of doing very, very important basic things for the game. You actually now have in front of you, if you have done this, a clicking game where you have a score that increases. You can see where you're tapping on the screen. You get an animation out of it. It is not a good game, I know, but this was the foundation. And when we are making a game like this, because we have all options open, we can do anything we want, it is a bit hard to do something very specific while opening up the project. What we have now is a clicking game without anything else. What I want to do in the next video, and I'm telling you guys that now, I want to add save functionality so that it saves your score. I want to add in a combo so that when you tap for some amount of time, you get a higher value. And I want to add in a purchase functionality so that you can get more per tap. Those are like 3 very important things I feel we absolutely need to have in a game no matter what. So those are things that I know is going to be coming in the next video. A combo option, a store option, just like one thing to buy that increase your tap value, and a save option. So those are the things I feel we need to add as a minimum. I want to keep the videos shorter than this one, but I wanted to make the first video in a way where you actually had something more than just a number. That is why I decided to add in the tap text as well. So I hope to be making shorter videos in the future focused around 1, 2, 3 small things. And I would really like for you guys to write in the comment what you would like to see in the future games. How should we update the game? You guys probably have a gazillion ideas, but please keep it to functionality and not graphics. So it's cool. I had a comment do something with pandas. Yeah, we can, but graphics are not important right now. And what I mean with that is what should happen in the game. In terms of developing, it doesn't matter if we're using an image of a butterfly, a panda, a spaceship, or a spinning pen, because it is just an image that we're putting in the game. The important is what kind of actions can we have, what kind of features do we want. For instance, if you want to have a gambling feature, then that is a feature. It could be a roulette, it could be a coin flip, it could be blackjack, it could be slot machines. Those are functionalities. But if you want to have a slot machines with cherries and bells and sevens, then that is not as important, because we need to make the mechanism first, and I want you guys to be able to theme things the way you want by putting in your own images. So think about what you would like to see. Please remember that we're moving from nothing and slowly up. So there are many really cool things we could do, and that would be amazing to do. Trading, online stuff, friends, connecting to Facebook, to Google+, to all these social features. Those are also a bit into the future. But everything that you can think of in terms of small game features is what we're going to be starting with, and then slowly but surely we're going to be branching out and opening up for a lot of other things. We could have, do we want to collect things? Do we want things to appear on the screen that we tap on to collect them, or do we just want to click anywhere? Perhaps you need to click only here on the coin or only on the tree. Perhaps we want something that increases whenever we have tapped it enough, like a tree growing or stuff like that. But don't hold back. Throw in all your cool, crazy, silly, amazing ideas. I will try to sort them in terms of what is realistic in small steps. And please, if you are doing this, if you made a game, if you made this, please send me a video. I would so love to see. Also, if you change things, also if you don't, and I'm going to be posting a link to my Dropbox in the description. You're going to be able to find these files there in case you just want them. And I'm going to make an APK file for Android devices and an iOS installer as well. So yeah, that was pretty much it for now, guys. As always, thank you very much for watching. Yeah, I'm not done yet, but I kind of cut it there, so I'm sorry. Thank you, guys.